Yeah, hey everyone, welcome to this month's GDG Sydney. It's great to be speaking to you all today, and also so many of you, which is great. So I'm wanting to talk to you all today about bridging the gap, which is just communicating with native channels in Flutter using a package called Pigeon. Just fair warning, you're going to see a lot of code, and I don't expect you to understand it all. If you do, that's great. But just fair warning, there's going to be a lot of code on the screen. Just out of curiosity, a bit of level setting. Who here is working with Flutter or has worked with Flutter? Few people, or most people. Who has actually communicated with native channels using method channels, maybe? Okay, few people. And who has actually used the Pigeon package? That's what I thought. So that's what I'm sort of wanting to introduce today is the Pigeon package. But first, just a little bit about me. My name is Luke Moody. I'm a Flutter and Dart GDE, also one of the organizers here at GDG Sydney. So if you do have a talk that you'd want to present sometime, then please let me know or let any of the organizers know, and we can sort of set that up. Also a Flutter technical lead, and you can find me at LukeMoody01 on most platforms, LinkedIn, GitHub, Twitter, or X. Does anyone actually call it X? Does anyone still call it Twitter? Yeah, actually, whatever your bend is, you know, whatever, X, Twitter. So the agenda for today is we'll cover why we need to communicate with native channels, how we communicate with native channels, and then what is Pigeon, how we can use and set up Pigeon, and then creating your own package using Pigeon, and then we have time for questions at the end, I hope. So the first question is, why do we need to communicate with native channels? Does anyone want to just have a shot in the dark? Why do we need to communicate with native channels? Yes, exactly. We do need to communicate with native capabilities to sort of round up our app. So just like you said, unlocking that native capability, we want our app to communicate with camera, GPS, notifications, that sort of stuff to make it just a better feel. We want cross-platform harmony, which we want something on Android to work the same on iOS. So we want the camera on iOS, camera on Android. We want it just to be sort of harmonized. Richer user experience or experiences. So the user will just feel more comfortable if your app, integrates with the underlying platform. It's just more home to them if they're using a fingerprint scanner. It's what they're familiar with, right? So it gives it that richer experience. Third-party integrations. If Android or iOS have a third-party integration, you'll still need to go through the method channel and then invoke it on that platform, like Android or iOS, Windows, web, wherever. Performance optimizations. This one I was a bit hesitant to put in, but there could be some cases where you write some Dart code, runs flawlessly on Android, but for some reason iOS they could jank. No idea why that could happen, but sometimes you may need to abstract or move that logic inside of the native platform for whatever reason. Could yield some performance optimizations. And lastly, platform flexibility. We want to be able to run our app on all platforms, or as many platforms as we need, right? And hooking into those native capabilities will allow us to just keep that platform flexibility. So writing custom platform-specific code. So Flutter does use a flexible system that allows you to call platform-specific APIs in the language that works directly with those APIs. Long way of saying, if you're going to develop some native code on Android, you can use Kotlin or Java, iOS, Swift or Objective-C, C++ on Windows, Objective-C on Mac OS, and C on Linux. And I imagine if you were to work with maybe Watch OS, it could be Java or whatever it may be. But that's just some examples. And this is just sort of a architectural or hierarchy or top view of how it works. So you have your client, which is the Flutter app, has a state, as you know, and it communicates via something called a method channel. And it uses a method channel to communicate with the host. So here we have iOS and Android hosts. And then inside of the respective hosts, they have their activity or an app delegate in iOS's case. And inside of this app delegate or activity, then you will then call the platform APIs, or the third-party APIs in that case. So just some examples here, just to sort of show how the Dart values are received on the platform side and vice versa. So, for example, in Kotlin, if you're communicating between Dart and Kotlin, if you send a bool, it'll be a Boolean type in Kotlin. pretty self-explanatory. And Swift, you'll see same here. I didn't list them all out, but you can sort of imagine what they would look like. So let's have a quick look at how it's done without Pigeon. So just raw, how you do it, the method channel. So I've grabbed this off the docs.flutter.dev website. So if you ever want to go back and have a look, it's just here. So we do have a stateful widget called my, oh, you can't even see that LED, my home page, and it has defined a variable called platform, which is just a method channel with this path. So we're just saying, imagine it as a tunnel. We're saying this tunnel is named samples.flutter.dev/battery. And inside of this, we also have underscore battery level, which is just unknown at initialization. We have a method called getBatteryLevel. And inside of this, we have a try-catch, or a try-on even. And we're invoking the platform. So we're saying, with this tunnel, or this platform, let's invoke the method getBatteryLevel. And it'll return as an int. And if so, we'll set the battery level. Else we'll say we failed to get it. And then we'll set the state and rebuild that widget. So that's all the Dart code you need. And then in the main activity, or in this case, myActivity.Kotlin file, we will have a main activity class. It inherits from a Flutter activity, or it implements Flutter activity even. And we have a private value channel, which is that string we've seen before, samples.flutter.dev. You get the gist. And then we have configure Flutter engine. So this is actually provided to us by that Flutter activity class at the top. And all we'll do is we're essentially using the binary messenger of the Flutter engine, passing this channel to say, hey, when we receive events on this channel, let's set a method call handler, and it will come through. So when we use that invoke method, or whatever it was, it would then come through into this to-do area. So what we'd need to do then, sorry, the format's different. I had to implement this because on the website I wasn't able to get the full thing. But we have a getBatteryLevel method. There you go, you can see it now. And there's some version checking. If it's a specific version, then we'll use battery manager, else we'll just use a context wrapper, and we're returning the battery level. Fairly simple stuff. And then now we say if the call.method, which is saying, if it's getBatteryLevel, we'll actually try to get the battery level, return result.success with the battery level, if it's successful, if not. So that's it. And if we were to run that, it would all work. It would give us back whatever our battery level is. And it looked pretty easy, but why would we use Pigeon if it was that easy, right? So I've put a few things here. I'm not going to read through all of it, but enhanced code generation. So it does automate a lot of these strongly typed Dart code from platform-specific interfaces, essentially. And it reduces our manual error, or human error, we can say, in our parsing of types and all that kind of stuff. Platform-agnostic interface definitions, just making it easier, reducing the risk of inconsistencies between Flutter and native code. Streamline development, if we have a team, we're saying we're going to use Pigeon, everyone sort of knows how to use Pigeon. It generates a lot of the boilerplate for us, so there's not really going to be many hiccups, you'd hope. Reduce potential for bugs, sort of went over that. And code maintainability is very much easier. Well, that's one of the main things. Having a maintainable code base is very important. And there is times, like imagine if we were to do this and we had to integrate camera, GPS, notification. We'd have to do all that, right? And you may say, well, there's packages for that. But there's times where you might have a client that doesn't want to use third-party packages and implement it yourself. Well, then it's going to get very messy if you have to do it like this. So how can we use and set up Pigeon? So I'm assuming a lot of you are familiar with the Flutter CLI. It actually gives us a good template called plugin. So we're able to say Flutter create. We give it an org name. In this case, it's dev.moody. Template is plugin, and we specify the platforms. That's all we have to do. And it's good to mention here that I've done -A, which is essentially saying, for Android, I want to use the Kotlin language. And -I want to use iOS for, or in Swift for iOS. And I've called it Prezzo. Couldn't think of a name. So it generates us this big folder or big package here, which is essentially, you're pretty familiar with this, I imagine. It's just a sort of the structure or architecture for a Flutter package or plugin. Losing my voice, I'm going to die. And I've also expanded a few things here. For Android, it's given us the dev/moody/prezzo prezoplugin.kt. And in the lib folder, it's given us a few of these classes to change or modify later, which we'll go through them now, actually. So it does give us, to begin with, in the demo_platform_interface Dart file, gives us essentially the interface. So that's all you really need to know here. This is an interface. A lot of this is standard. And here is the actual method channel. So you've seen this before in that recent slide. We've just given it demo. And we're invoking method getPlatformVersion. So this is what's generated for us, by the way. We will be modifying this. But it's a good starting point, that's for sure. It also gives us a demo class. And then we're able to say demo_platform.instance. So we're just abstracting this again. So I've said here the wrapping class for dependency injection and just an abstraction. And I've also given it an interface here. And the actual plugin Kotlin Android plugin gives us something similar to what we've looked at before with that example. The only thing different is it's given us a method call handler, which just replaces this on method call stuff that you've seen before that was initially on attached to engine. So how do we modify this and what are we going to change? We'll add Pigeon as the dev dependency. It's not something that we'll actually need to use besides in the dev dependency area. Whoops. And to use this package, we actually need to create a folder. It doesn't have to be called Pigeons, but just for standards, we can call it Pigeons. And inside of it, we've created a class called messages.dart. This is just what I've seen, the standard being messages.dart is going to create or hold our configuration even. And inside of this class, all we've done is we've created, or we've used this annotation, configure Pigeon. We've given it Pigeon options, which is just a class that's provided by the Pigeon package. We've said Dart out, so the generated files for Dart, where do we want that to be generated? Inside of this lib folder, that's fine. Test wants to be outside of the test, inside this one. And then Objective-C, Java, I don't need to go through all of them, but they will be outputted in their respective folders, or files even. And then inside of the same class, we've also added our custom class. So what do we want to be passed between the platforms? We said prezo details message has a string int. And we've also defined our API down here. We said it's a host API. We've given it an attribute of host API, which comes from the Pigeon package. And we said it has a get prezo details, it passes a parameter, and it returns us this custom class here. So the reason I've said pass parameter inside the prezo details message is just to simulate that we can pass a parameter in to a platform, and it can be returned back out in another class or by itself. And then to actually generate the code, we use the Pigeon package, so Dart run Pigeon, giving it the input of the messages.dart file. And now we'll actually demo it instead of just hypothetically going through code. So this is where things could go wrong. Let's have a look. All right. Can everyone see this? Should I, is that better, or should we need one more? One more? I can't see now. Oh, cool. All right. So we're actually just going to create a package or a Pigeon package from scratch here. Hold on. OK. Just ignore these ones. These are just ones that I've been working on. So we'll just minimize this. So first step was to create the plugin package. We'll call this, I don't know, calculator. So we'll create a calculator, a native calculator plugin. Sure, that's fine. So what this will do is it will create us our folder that we've seen before. Did I run this command? No. So go inside a lib. And we'll see we've already went through this, but gives us the base method channel, the platform interface, a web actual handler, which we'll get into later, and then the actual wrapping class. So it's saying that it can't find any of these plugins. Ugh, that's great. We'll try and pub get. Any luck? No. So we're going to have to do a bit of this. There's always something that goes wrong, hey? Cool, so it should be fine now. All right. So the next thing for us to do is we have our base classes here. Now we just need to add the Pigeon package, which lucky for me it's just here. Couldn't find it. Oh, great. There we go. So we'll add the Pigeon as part of our dev dependencies, which is done. That was quite quick, actually. And if we check inside of here, it is now, here it is, Pigeon, which we can now create our folder, as mentioned before. Pigeons, and then inside of it, we'll create a messages dot. Dirt? Nope, that's not what I want. And I am going to cheat. I'm just going to take this one, and I'll bring it over here. So this is sort of what you've already seen already. We have a Pigeons options, configure Pigeon. We've given the output, but this time we'll give a dev.moody, and it's going to be calculator. Oops, calculator. And same with the package. So we're all good there. We will then create a calculator API. Oops. And we will say, I don't know, get calculation. And we'll keep is working just because I want to simulate having multiple methods so you can see how simple it is to add methods and remove methods. And we'll keep a GDG message. Why not? We'll just keep this. So now that we have all that, we can now run the Pigeon command, wherever that may be. This one? Yes. Although it should be Dart run, but Flutter pub run also works. It's telling me it's deprecated. Yep, that's true. Should be using Dart run. So it'll do this, it'll build Pigeon, and it will generate all of the files. Now, we didn't really deep dive into what it generates, but let's actually have a quick look so you can see. So this is all generated. We don't modify any of this, but it's created our class, which is the GDG message. It's created an encode, a decode, and then also creates that codec that we've seen before as it switches between native and Flutter. And it also creates our API for us. So it says, it does all this stuff. I'm not going to go through all line by line, but it generates a lot of the boilerplate for us inside of Dart. And if we go into Android, it also create our plugin, which I can't really open on VS Code, but it generates this here. So what we need to do now is essentially change our implementation to use this API. So we'll do that now. So we'll just call final _ API equals calculator API, if I can spell. So if you're worried about, I guess, injection or dependency injection, you could just create a constructor. So method channel calculator, and you could then inject the API if you wanted to. You can do that, but just for demo's sake, we'll just call it, or we'll just create an instance of it here. And now we need to we'll have final, or we'll do result _ API dot, and we can start calling our methods now. So get calculation is fine. We need this to be get calculation, and it's going to return us our GDG message that was generated, and it's going to pass in int past parameter, and it will be asynchronous, of course. Most, if not all, platform calls are asynchronous. So we have a result, we can return result. So simple enough. We'll also probably need to grab our isWorking one as well, which will return a bool, is working, which is all good. We'll need to update our interface to say, hey, these are the methods we want. Well, let's just copy paste, eh? So we'll just copy paste this over here. So this is just our interface. And we'll just say, oh, isWorking has not been implemented, or get calculation has not been implemented. And now we implement this. So now we're technically all done. We just need to update our actual class. Because we could just say calculator.platform do whatever, but I like to wrap it inside of another class for dependency injection sake or mocking sake. We can do such thing. So, should we just copy and paste again? That'll make life easier. So we copy paste this in here. We can remove these overrides. Ideally, we would have a interface class here, like for example, what you saw in the demo. So abstract interface class, and it would be iCalculator, right? But we won't do that for now. Make things simple. And then we do calculator platform dot instance, and same thing here. So our Dart code is now pretty much done. We'll need to update the example to use our, the correct implementation. So get calculation is working. We'll do that in a second. So Dart code is done. Now we need to implement it on the Android side. And what I figured is if you open this in Android Studio, the actual plugin, it never works. But if you open the example, it actually works. It gives us IntelliSense, which is crazy. So let's trust the project. We'll open this. And this could take a while to load, so we'll actually just fix the example while we're here. So we are using the calculator plugin. We'll say get calculate. Get calculation, that's the one. We'll pass 12 as our pass parameter, could be whatever. And we return a GDG message, right? And up here will be a GDG message. Can be null. That's fine. GDG message. It never works for me. Oh, there we go. Oh, that's so good. So we'll take this to GDG message. Have this as an underscore though. This is going to complain. We change this to null. Make this nullable. And GDG message, we'll do underscore GDG message dot, oops, let's do dot, and is GDG awesome? We'll do platform, because that's what we want to test, and if it's null, we'll just say unknown. That's fine. Oh, I cannot spell today. All right, so we've just changed this to use the calculator plugin, and we've actually used our get calculation instead of get platform version. Hopefully Android is done by now. Nope. What can we do? Integration tests. So the plugin actually gives you integration tests, which is actually pretty awesome. Not many do that. Oh, just in time. So in our Android, we now have our Gradle, main, and we have our Flutter. What is this? Is it in here? Yep, this is the one. No, it's not. See? Never works if I want it to work. We have main activity. That's not what we want. Let's open up. Mm-hmm. Now I need to wait for this one to load. All right. So it's generated our messages.java and our calculator plugin, but one final time we'll actually need to open the example because it doesn't give us IntelliSense otherwise. Please work. I promise it worked like 2 hours ago. Demo gods do not like me. All right. I'm not that familiar with Android Studio. Top left. File. Open. All right, we'll see. That's what I thought I did, but through. We'll give it another go. If this doesn't work, we will. I swear that's not me. It does sound like a pigeon, but that's not me. Pigeon. I mean, yes, I've added sound effects throughout the. All right, what we'll have to do is I don't know where that came from, by the way. Let's turn that off. All right. What we'll have to do instead is we'll just have to open up this GDG Sydney one, which is going to be basically the same code. That is okay. I promise you I'm not scamming you all. Now, if this doesn't work, that's going to be a real issue. Let's see. This window. And the answer is... While that waits, what can I explain? So pretty much the exact same code we have in this GDG Sydney one. Oh, see, this one decides to work. Who will never know? We will never know. So pretend this is calculator. And it's given us, obviously, oh, please. It's given us our Java here. So this is our generated messages. So this is what Pigeon generated. All the parsing and all that stuff is sort of done for us in here. See, I would never be able to write this because I don't know Java that well. So this is a big hand. So what it did generate for us is this. Please open the file. Thank you. So it did generate us this before, but it just didn't have this GDG API. So if it was the calculator one that I had, we would do calculator API. So we just inherit from calculator API, and we'd then have to actually give our methods. So is working, get GDG details, pretend this is just get calculation, and we would give us a GDG Sydney. So what this is our implementation over here. So we created a class just like we did in Dart called GDG Sydney, or calculator in this aspect, and we've then implemented the functions. Get GDG details and is working. So here is where you can get the battery level, integrate with any third-party APIs, do whatever you want here. Could be asynchronous, could not be asynchronous, whatever. Then you return the message, and that's all you need to do. And then you just use that class inside of our plugin. It's a shame the calculator one wasn't working, because now it just seems like I'm showing you code that magically works, but I promise that this is how it works. And all we need to do now is, instead of using the Flutter binding .binary messenger and then the set method call handler, we'd actually just GDG API, this is what's generated for us inside of the messages, .setup, pass the messenger, and then pass itself. And then when we're detaching from the engine, we still want to set up the GDG API, but then pass null because we're wanting to dispose, essentially, and then setting that to null. I will post all of this on GitHub as well, so you can actually have this example. But so pretend I've written all that. That saves like 5 minutes. So if we run this app now, see if this doesn't work, then we have debug. No? All right, there we go. So what we should see is we're calling on init. We're saying GDG message. Oh, let's actually put a breakpoint here. Oh, breakpoint. Haha. So now we're able to see we actually did communicate with the native channel. We've got the date. Is GDG awesome? We set as true. We passed the parameter 12, and we got 12 back. So you could manipulate that however you want. The platform is Android. And now we can set the state. So currently unknown. As soon as the state is set, it changes to Android, which is pretty good. And we can actually just change this. Well, let's just change this now, so I actually am writing some code. Let's go into Android, source, main, Kotlin. So let's go to our implementation, and we'll change this to false, and we'll change this to def not Android. And if we restart, I don't know if hot reload will work actually. I don't think so. Imagine if it did, that would be crazy. No, okay. So let's quickly just run this again to show that you can change the plugin. It's fairly simple. And say you wanted to create a new method, all you would do is literally go inside of the Pigeon folder. That's when the noise should play, the pigeons. And we'd create a new method, any new classes you can have up here, and then generate, and then implement it as such. So now we'll get a new message, false, def not Android, fairly simple. So that's good. And just to show, because I know some people are curious about iOS code, it does generate that. If you're doing Swift, obviously it's going to generate a Swift plugin here. And I imagine you would then override the messages API up here as well, and then implement it, however. And then messages, I understand none of this, but it generates this as well, which is pretty cool. And yeah, so let's jump back to the presentation. Oh. Bear with me. See, this is not me. All right. So, hello. There we go. So, what about web? So, we did mention, how things get passed to each platform, but we didn't mention web. And it's handled a tad differently. It is handled via, two different ways. You can use JS interoperability. Took me ages to remember how to say that properly. Or the .html library. And this is just a quick example of how I've used it. So, for example, I wanted to create I wanted the app to play some audio from an array. And none of the packages that I found actually worked on web Safari on iOS. So then I had to just create this myself. So if you know JavaScript, don't critique me. This is what I just found worked. So created this. It returns a new promise, creates a buffer, and returns us when it's finished. And in the Dart side, we create a JS library. And we attribute our method with, what it's called. So if we just step back for a second, play audio from unit 8 array. We've attributed this with play audio from unit 8 array. So this will be mapped to that method, or that JavaScript method. And play web audio, it uses this method, or an external method, and then it does a few completer and returns the future. And what that looks like, inside of a block or some logical component, you'll have play audio, and it plays the web, play audio web through this audio bytes. And creating your own Pigeon package, I think I've been going for some time, so I'll quickly just show you an example of a package on popdev. I can put this one down. So, I'm not sure if any of you have used Wakelock before, but Wakelock actually uses the Pigeon package, and it does it in a pretty nice way. So if we go inside of it, it has the main Wakelock package, so it has the Android and iOS implementations inside of here. So it does, why is nothing, okay, here we go. Oh, devastating. Yeah, nice. So the Wakelock package, I've actually just been playing around with it, but you have the toggle is enabled message that they've created, and they're also now Dart outing their interfaces. So it's just abstracted from the actual implementation. So they've created another package, which is essentially just the interface and the method channel. And here they're using that API just like this. They're saying is enabled, return, and you're able to toggle, create a toggle message, send it back and forth. And then they have their interface here, which is a tad different to how we've done it, but we only had so much time, and then you've seen this before. But they've just extracted it into 3 different packages, or platform-specific packages. So Android, iOS, they have their Windows package here, and I don't think there is such a thing for web, but if there was, they'd extract the web as well. So that's also a good example to go off of. And let's just whip back from current slide this time. That's pretty good. And that's it. There was a lot of code, so yeah, maybe review this, or I'll upload it onto GitHub, and you can have a look there if you need to. Is there any questions from anyone? I'm actually really curious to what that is, and yeah, I thought so. Yep.
Thank you for presentation. I have a quick question. Could you please open one of the Java file or like Objective-C? Because my question is that, can you like customize which like asynchronous like library can use like combine in iOS or like coroutine? The point is that because one of the like strongest part of the channel is that you can use the native. Imagine you can use like combine in Swift and then get like many good like asynchronous programming, or you use other side of coroutine. I want to see like which library that you are using, like Pigeon is using there. If you open like one of the Java file,
yep.
or not the message you're sending, like not the communication channel is.
Are you on about for?
I'm looking for. Okay, just hold it. Yeah. Okay, got it. Oh, good. Yeah, understand. Yeah.
Oh, okay, awesome. I had to say nothing. Cool.
Yeah, it's because I think that one of the like weak point of this one, you cannot customize if you want to like using any like background thread or something like that in native
yes.
one, then you just stuck because this one using I'm sure like the native things you're getting added. You cannot like add any library or something like that. You just integrate. Okay,
yeah.
Thank you.
No worries.
Hello, great talk. Just a quick question about the debugging your code. Is it better to debug your code for the platform side or to the Flutter side, like for breakpoints and everything?
So if you're running the app through VS Code or you're running the Flutter app, you won't be able to debug, obviously, Android or any platform-specific code. But you could run the platform-specific code in like isolate and then test it. But I'm not sure how you'd actually test sending messages back and forth. So my experience is trial and error. You implement it on the platform side and then debug it on the VS Code Flutter side.
Oh, okay. And one more question.
Yeah.
Also, for the website, are we able to use like are we fixed by JavaScript, or we can use TypeScript and other like type of?
Oh, I haven't tried it with TypeScript. JavaScript, yes, is fine. I'd have to not deep dive into it, but that's probably a whole nother talk, just integrating with web and embedding Flutter onto the web. But yeah, I'm sure you could communicate with TypeScript somehow via some parsing, but yeah, I'll have to take a look and let you know about that. Yeah.
Yeah. Thank you. Thanks.
There you go. Thank you. I think there's someone at the all the way at the back.
Question about the iOS deployments. I don't know if you've experienced that, but in my experience, it's not uncommon to have some issue with a third-party framework with iOS during deployments. Is that something you've experienced?
All the time, yep.
Yeah, not just iOS.
Yeah, no, yeah, iOS, when building, there's always a lot of issues with pod files. They always give me trouble. Not so much recently, because there's some scripts that you need to sort of know to begin with, where it like sets all the versions to a specific iOS version, and then it sort of works. But I'm not sure what sort of issues you're talking about in particular, but I'm happy to chat with you if you needed any.
Just curious, really.
Yeah. I mean, it happens.
It's
Yeah,
notorious.
Happens all the time.
Issue.
Yeah. Some packages are newer than others. Some are older and they conflict. And yeah, sometimes you'd have to find a happy medium between the two.
Cool. Thanks.
No.
Right. Maybe we just take one more question and
Yes.
wrap up.
Oh.
From an experience like using that, would you say it's worth it? Keep using it that package, or would you go the path of if you go get some very complicated stuff native, you would just do that yourself on a native code, native project?
I'd say yes, it is worth it, because it's good just to have this knowledge and to be able to implement anything you want natively. Say, I'm I remember when the dynamic island came about, everyone was rushing to sort of figure out how to implement that through method channels and all that kind of stuff. So it's definitely a powerful tool, and I would definitely recommend sort of even just playing around with it on a custom project or personal project.
Oh, okay. I had one. So
Yep.
it's about the wake lock.
Yes.
So that one would be a replacement to the Pigeon, or will it be a separate plugin that uses Pigeon to create?
Yeah, so WakeLock is a plugin that uses Pigeon to generate its APIs, just like we've done before, and then implements like keeping the app awake while you're backgrounded, for example. So that's all WakeLock is, and it just uses Pigeon to generate those APIs and those classes that they pass back and forth.
Thank you.
No worries.